Hello everyone. So today I'll be starting the chapter on pair of linear equation in two variables. So now you are familiar with linear equation in two variable that you have studied in 9th class. Now let us recapitulate. So what does a linear equation in two variable mean? Suppose let me give an example. Say 2x plus 3y is equal to say 1. So you see here there are two unknown variables x and y, and their power is 1. So this kind of equation, that is the general form of a linear equation in two variable, is ax plus by plus c is equal to 0, where a cannot be 0 and also b cannot be equal to 0, because if they are 0, these two variables will not be there in the equation. So then the equation will be no longer in two variable, it will be in one variable. If suppose b is 0, it will be in one variable x, and if a is 0, it will be one equation in one variable in y. And if both a and b are 0, then it will be only constant will be left. So that's why this condition is important. A cannot be 0, b cannot be 0, and together we write these two equation can be written in this form. It is this is equivalent to your a square plus b square is not equal to 0. Why? You see, if a square plus b square is equal to 0, then a square will be equal to minus b square. Now that is not possible, because we know square of any number cannot be negative. So the only possible, this is possible only when these terms separately are zeros. These two terms separately has to be 0. That means a square has to be 0, b square has to be 0. That means a has to be 0 and b has to be 0. So this will not be equal to 0 only when these two conditions are satisfied. So instead of writing these two, if I write this one, meaning is saying that a, b are non-zero real numbers. So this is the general form, and so the main thing, the power of the two variables will be 1, and okay. And why it is called a linear equation in two variables? Because if I plot a graph of equation of this type, we will always get a straight line. Okay, so that means this equation in the standard form will be 2x plus 3y minus 1 is equal to 0. So if I plot the graph of this, I'll be getting a line. Suppose x-axis, y-axis 0. So it will be a line. Okay. So it may be, I am not plotting the graph up to exact points. So it will be some line. Okay. Actually, if I can plot it in this way, it will be something like that. Oh, sorry. Straight line. Anyway, it will be a straight line. So let us assume whatever may be, it will be a straight line. This equation. So ax, let me write in general, it will be better. So graph of a linear equation in two variable will be always a straight line. So you see there are infinite many points on the line. So each point is satisfying the equation. That means each point is a solution of the equation. So from a line, from the graph of a linear equation in two variable, I will be getting infinite many solutions. Okay. Now suppose, let me take an example, it will be better. Let me take some example. Suppose you have two variables x and y. let me take them as two numbers, say, such that their sum is, say, 5. Sum is 5. Then that means these two variables are related by some condition, that is their sum is 5, always 5. So, or I can write in the general form. So I got a linear equation in two variable. So now, and I want to find the numbers which satisfy this, a particular number I want, but from this it has infinite many solutions. But suppose along with this some another condition is given which is fulfilled by the two variables, then what will happen? Suppose the other condition given is, say, if I subtract the second number from twice the first number, okay, the result is 1. Or let me write in this way, twice x minus y minus 1 is equal to 0. That is equation 2 in the standard form. That means, you see, two relations are given which are satisfied by the variables, two numbers. One is this, when I am getting this equation, and another is this. So you see, so from this I will be getting a line. Let me plot the graphs now. X plus y is equal to 5. It will be something like that. I know it will be your 5, 0, and this point will be 0, 5. X plus y minus 5 is equal to 0. And if I plot this graph of this, that means what is this? Is your y is equal to twice x minus 1. So you know how to plot the graphs. Let me take, say, 1. 2 minus 1 is 1. Let me take 2. It is your 3. And let me take 0. It will be minus 1. 0 minus 1 will be somewhere here. Say 1, 2, 3, 4, 5. So it will be minus 1 will be this point. Minus 1. So this is 0 minus 1 is this point. 0 minus 1. 1, 1. So again here it is 1, 2, 3, 4, 5. So 1, 1 will be here. This point. And lastly 2, 3. 2, it will be here. 3. 2, 3. So if I join this, I will be getting graph of the second equation, twice x minus y minus 1. So you see these two lines, that means this line, both the lines are satisfied by these two variables. So the common solution is the point of intersection. That is, at this point of intersection, what happens? This is the point 2, 3. So this is your 2, 3. This is the point of intersection. So at the point 2, 3, both the line passes. So this point satisfies both these lines. That is, both the equations are satisfied by this point of intersection. So that means this will be the common solutions of the two equations. So to know the values of the unknown variables, I need minimum of 2 lines to get the point of intersection, which will be the common solution. So that means I need a pair of linear equation in two variables. That's why we have to study. Well, that's why I need the pair. So you see the equation 1 and 2. So I can write in this way now. That is x plus y minus 5 is equal to 0. That was equation 1. And second equation, twice x minus y minus 1 is equal to 0, equation 2. So this is the pair of linear equation in two variable. Two variables, so two equations, a pair is required. So in this chapter mainly we'll be dealing with the methods of finding solutions from pair of linear equations to variables. Okay, so this is the idea why I should study the pair of linear equation in two variables. That's why the pair is required. Now let me write down the pair of linear equation in their standard form. And the standard form, so this is the standard form. Now since I'll need a pair, so I take this as the first equation, so that I put 1 in the suffixes for denoting the coefficients in the first equation. Then similarly the second equation can be written in this way. So this forms the pair of linear equation in two variable. Now again, what the condition to be fulfilled, because a1 cannot be 0, b1 cannot be 0. So where I write where a1 square plus b1 square is not equal to 0, and similarly from the second equation also a2 cannot be 0, b2 also cannot be 0, and together I write this condition, these two conditions to be fulfilled. So this is the pair of linear equation in two variables, standard form. Now we have to find the methods of solving this pair of linear equation two variable. So there are two different ways of solving them. First one is graphical method of solution, solving pair of linear equation in two variables can be categorized into two broad ways. First one is graphical method, and the second one is the algebraic method. The graphical method already I have explained you what to do. We have to plot the graphs of the two equations given in the pair. This is the pair actually. And then from the point of intersection I will be getting the solutions. Means the value of x and y which will satisfy both the equations. And the algebraic methods, there are again three methods. First one is method of substitution. Second method is method of elimination. And the third one is the method of cross multiplication. Now when we have to solve by algebraic methods, we have to choose any of these three. And how will you choose that? We have to some criteria we have to think about. Generally the method of substitution is suitable when the coefficients of any one of the variable is 1 or very small. And elimination, if the coefficients of the variables are not 1 or some other numbers. And cross multiplication method is a general method which is that is it gives a formula. Actually it gives a formula for finding the values of x and y. That is what is x will be some formula and y will be some formula. So we simply directly put the values in the formula and get it. And this formula is obtained by either by the method of substitution or by the method of elimination. Okay, so it's a general method. Cross multiplication method is a general solution method. Okay. Okay, now today I'll be first focus on the graphical method. First we'll go to this. The question will be given in this way: solve graphically. The given pair of linear equation. Given pair of linear equations. So what are the equations? 2x plus y, 2x plus y is equal to 6, first equation, and the second one is 2x minus y plus 2 is equal to 0. And also there are also remaining part of the question, that is find the ratio of the areas. Find the ratio of the areas of the triangles formed by the lines 1 and 2 with x-axis and with y-axis okay. So this is the question. Whenever solve graphically means you have to plot the graphs of the two equations, and from the graphs we'll be getting the solutions. Okay, so let us first plot the graphs. The first question, equation 1, what does it give? Y, and always express y in terms of x. It will be 6 minus 2x. So we can form the table x, y. So you see, if x is 0, if you put 0, 6 minus 0, it will be 6. If you put x is equal to 2, 2 to the 4, it will be 2. And if you put 3, then 3 to the 6, 6 minus 6, 0. So very easily we can form the table for plotting the graphs. So let me plot the graphs here. Okay, let me first form the tables. This is from equation 1. So from equation 2, what is y? Y is equal to 2x plus 2. Y take the other side, so 2x plus 2. So again, let me form the table. If x is 0, put x 0, so 2 is left, y is 2. X is 1, then 2 plus 2, 4, and then take x2, 2 to the 4, 4 plus 2, 6. So let me plot the graphs. X-axis 0, plot the first. So let me take this point to be 6. So So it will be 3 here. So 1, 2. We'll be plotting on the graph paper. Here I am doing the sketch, rough sketch. So let me take 1. Maximum value of x is 3. So okay, say this is 1. I can take different scale. So like this. So now I have fixed the scales on the both the axes. Now I have to plot the point. 0, 6. 0, 6. This is the point. 0, 6. Then 2, 2. 2 here and 2 here. So here it is here 2. 2, 2. Then 3, 0 is this point. So I have to join this with the help of a scale. So this is the graph of the first. So let me write equation 1. This is the equation 1 I brought it. Now this 0, 2. 0, 2 is 0, 2 is this point 0, 2. Then 1, 4. This is 1 and this is 4. 1, 4. Then 2, 6. 2 and 6 is here. Somewhere here. Right here I think. 2, 6. So you have to join this. So the common point, this is the point of intersection. What is that? It is approximately 1, 4. That's not it. This is approximately the same point here. So this point is 1, 4. So the two lines, this is equation 2. So the two lines intersect at the point 1, 4. So this gives us the solution. Solution. What is the solution? X is equal to 1 and y is equal to 4. So solve graphically, this part is done. So we write in this, since the lines intersect at the point 1, 4, hence the solution, required solutions are x is equal to 1, y is equal to 4. That is the point of intersection gives you the solution. Next part, find the ratio of the areas of triangles formed by the lines, two lines with the x-axis and the triangle formed by the lines and the y-axis. So the first let me find the triangle formed by the lines and the x-axis. So this is one line, this is another line. So this is the triangle. This is the triangle. So give a name, say A, B, C. So now I have to find the coordinate of this point. That is the line to intersecting x-axis. That means at any point lying on the x-axis, for any point lying on the x-axis, y coordinate is 0. So y is 0. So in the equation 2, here 2, it is 2. So if y is 0, let me see what point I get. If y is 0, what will be? 2x is equal to minus 2, x is equal to minus 1. So this point will be minus 1, 0. And C is your 3, 0. So I know this is the triangle ABC. So triangle ABC is triangle between lines and x-axis. That I've shown you. So therefore area of the triangle ABC is half base into altitude. What is base is BC. And what is altitude? This is the altitude. And this is same as this. So altitude is 4. So altitude is 4. And what is BC? BC is actually here 3 unit and here 1 unit. So 3 unit plus 1 unit, so whole is 4 unit. So I can write 4 unit. So it is equal to half into 4 into 4. So that is 4 to the 8. 8 square unit I must write. So the area of the triangle ABC, that is the area of the triangle formed by the lines and the x-axis is found to be 8 square unit. Next, let me find out the area of the triangle formed by the lines and the y-axis. So this is one line, first line, this second line, and this is y-axis. So this part, this is the triangle. Say give a name A, B, C, say D, and say this point is say E. So triangle ADE is the triangle between lines and y-axis. So area of triangle ADE, half base is your, say ED is the base, ED into, this is the altitude, this, and what is this length is now equal to this length, that is, this is the altitude H, is 1 unit, so 1. So is half, and what is ED, you see, this is ED. ED will be equal to OE minus OD. What is OE? OE is the ordinate 6. This is 6. So you see this is 6 minus 2, that is 4. This is the base of the triangle. This is the base, and that is your 4 unit. 4 unit. 6 minus 2 is 4. So I can write ED is equal to 4. This is 1. So it is equal to 2 square unit. So 8 square unit is this, and this is 2 square unit. Okay. So I have to find the ratio of the area of the triangles. Therefore, required ratio will be this area of triangle ABC is your 8, area of AD is 2, that is 4 by 1. So the answer is 4 is to 1. So this is the ratio and this is the solution. These are the two answers, solutions and the ratio. So in this way we plot the graphs on the graph paper, and from the point of intersection getting the solutions, and then we shade the triangles between the lines and the x-axis and find its area by the formula half base into altitude. Then we shade differently the triangle formed by the lines and the y-axis, and similarly by half base into altitude we find the area of this triangle, and then the ratio of this triangle, ratio of the area of this triangle and this triangle, we get it 4 is to 1. Okay.
Stop here.